PID controller. समस्त निज MATLAB open करो. Okay, go to library, search PID. Are you getting a PID controller? देखो समस्त पे simultaneously करो. ये शेयर कर स्क्रीन शेयर करो जाने from each group. All of you can generate the block, yes or no? Simulink model. Okay, so first of all, you can take the step response. Okay, next you can add, see, like this. You can design, yes or no, step response, and this is the summation point. In this PID controller, if you double click on this block, okay, listen, those who haven't joined yet, please join in B2 group only. Everyone, please join in B2 group only. जो मैंने B1 टा already अच्छा stay there. जो मैंने नया join करूँगा, kindly join in B2 group. Okay, so this is step response. Okay, so now in this PID controller, if you double click on this controller block, you will find PID. The parameters are there. Okay, this is another one. See, these are the parameters PID, proportional PID parameters are there and the filter coefficient is there. Okay, so if you open that one, already some of them are present. Okay, is it visible to you? My screen is visible to you or not?
Yes, yes, ma'am.
Oh.
Yes, ma'am.
Okay. So you will see if you this is another one. I have already tuned this PID controller. But a simple open inbuilt some values are there. Okay, small amount of values will be there. So just if you want whatever values you have already taken, you can directly put it there, or you can adjust them by hit and trial method. Okay. So if you next is your transfer function block. Okay, you can take the transfer function block with initial stage I have taken. So you have taken your transfer function block where you can give your numerator, denominator, whatever you have taken, your transfer function directly you can take it here. Okay, and this is the KPI KD values I have taken here. Okay, so then you can take your scope. If I can say there is an experiment to design a first order and second order PID controller. Yes or no? Have you gone through your list of experiment? So, design a PID controller for first order and second order system. Okay, that is there is another experiment. This is your experiment number 8. After PID, you can write down this one. Design of PID controller for the first order and second order system. So, first order, second order system. Any example you can take. This is 1 divided by s plus 4s. This is which experiment? Oh, sorry, which order? Right. Similarly, you can take any first order example. तो मैं नीचे नहीं पारिबो, है ना? Then what you have to do? You have to design the PID for that. So already inbuilt some values are there. By using hit and trial method, you can add your KPI value to adjust करके you can get your output. Okay. So the output should be smooth. Okay. Next, this is another one. I have taken another example, and the parameters I have taken like this. Okay. So if you want, you can directly another process is there, the tuning method. I hope you know that process control have already provided, right? Tuning method. Yes or no? See, this is for P controller, this is for PI, and this is for PID. What a Ziegler-Nichols method is. If you are going to use Ziegler-Nichols method, suppose I am giving you an example, you can write down G of S is equal to 1 divided by S into S plus 1 into S plus 5. One divided by S plus 1. Okay, suppose this is the transfer function I have given to you. So what is the steps you have to follow? What are the steps? First one will Ordinary frequency number କାଇଁ ଗୋଟେ plot design କରିବ କି EID value କାଢିବାର ଅଛି ନା normal form no that is your characteristics equation. First you have to take your characteristics equation. Okay, then what you have to do, you have to go for RH criteria. You have to apply your RH criteria method, right? From there you can find out your marginal value, that is KU. Yes or no? From there you can find out your marginal value, that is your KU, this one, right? So can you tell me what is the value for this one? Tell me. S divided, sorry, 1 divided by S into S plus 1, S plus 1. What is the characteristics equation? Okay, if you go for the frequency, sorry, first you will find out the omega value, ultimate frequency, that is omega u. What will be that? How will you find out? See, your characteristics equation will be Hello? Honestly. Characteristics equation कौन है? X cube plus 6x equals to 0. Then you have to take S equals to j omega, right? You have to take S equals to j omega. Then this will be okay. Plus for PID, if you are finding for PID, plus Kp value will be there, right? Plus Kp equals to 0. Then put S equals to j omega. You will get Kp minus plus Kp equals to 0. Then put S equals to j omega. This will be j omega to the power 3, 6 j omega square plus 5 j omega plus Kp equals to 0. Now by solving this, you will get Kp minus 6 omega square. This is your real part. And what is your imaginary part? 5 omega minus j equals to 0. Right? Then what you have to do? You have to make imaginary part 0. Yes or no? Now the step is you have to make the imaginary, you have to equate this with 0. 5 omega minus omega cube. So this is 5 omega cube equals to 0. Now equate this, you will get, by solving this, you will get omega equals to 5 radian per second. You can consider this as omega u, right? Now, next step is to apply the RH criteria. To apply RH criteria. While applying RH criteria, you can apply your RH criteria. So that will be is to the power 1 to the power 0 1 5 where it will be 6 kp. Is it correct? Or I skipped any term? Is it correct or not? It is another s cube plus 6x square plus 5s plus kp. Yes or no? So this will be 6 into 5, 30 minus kp divided by 6, and this will be 0. It will be kp. 30 minus kp divided by 6 into kp minus 0 divided by this much. So remaining is kp, right? So now to find out the ultimate gain, you have to make this auxiliary value equal to 0. Now, right? Why? Because if this is in the same sign, positive sign, then this will be, the system will be stable. Yes or no? So that for that you are making this greater than equals to 0. So you can say 30 minus kp is equal to 0. Hence the ultimate value for kp, or I can say ku is equal to 30. Ku is equal to 30. So you get your ultimate gain value 30. So now how will you find out this Tu value? is equal to what? 2 pi divided by omega u. Okay. So by using these parameters, directly you can find out Kp, Ti and Kd value. If Kp, Ki and Pd value is there, how will you find out Ki value? How will you find out Ki value? Ki will be Ki is equal to what? In terms of Ti, tell me. More than Kp divided by Ti and your Kd value is Kp dot Td. Okay. Kp divided by Ti and this is Kp dot Td. What is the general transfer function for PID? What would you? Yes? KDS. Achha, in terms of Ti and Td, right, you can take Kp common, so it will be Kp into 1 plus Kp plus Ki divided by S plus Kds is equal to 0. Now you can take Kp common, so this will remain 1 plus Ki divided by Kp, because I have taken Kp common, S plus Kd divided by mute karo Kp into S. Right? This is not. Kd divided by Kp into S like this, right? So now you can take let Ti equals to Kp divided by Ki and Td equals to Kd divided by Kp. This term. Ki divided by Kp, this term. Kp Ki divided by Kp is plus Kd divided by Kp into S, right? So now I'm taking Ki divided by Kp and Kd divided by Kp is Ti and Kd respectively. S Ti and Td respectively. So it will be Kp into 1 plus Ti divided by 1 divided by Ti into S. Taking this is 1 divided by Ti. Okay. And this is Td. Because Kp divided by Ki and taking is Ti. K equals to Kp divided by Ki. And Kd is equal to Kp into Td. Okay. You can keep these assumptions and write down the equation. From there, you can find out directly Kp plus Ki divided by S plus Kds. This is the transfer function of PID controller. for Simulink, you just don't need to derive this transfer function. You just have to find out the KPKI KD value. KPKI KD value for your PID controller. Okay. So this you have to perform this experiment. Experiment ଏବେ ନିଜେ କରିପାରିବ simple ଅଛି Simulink step response you have to give a step response just PID controller transfer function you can see your step response ହେଇପାରିବ ତ ହଁ ନା ନାଇଁ ସେ ହଁ ମୁଁ ତମକୁ ଗୋଟେ ଥର୍ଡ ଅର୍ଡର ଦେଇଛି ଠିକ ଅଛି ଏଇଟା ଗୋଟେ ନବ एक्स्ट्रा ତା ସହିତ ଗୋଟେ ଫର୍ଷ୍ଟ ଅର୍ଡର ଆଉ ସେକେଣ୍ଡ ଅର୍ଡର ନବ ଫର୍ଷ୍ଟ ଅର୍ଡର ଆଉ ଫର୍ଷ୍ଟ ଅର୍ଡର ସିଷ୍ଟମ ପାଇଁ ତମେ ଏଇଟା ଆପ୍ଲାଏ କରିପାରିବନି ଜିଗ୍ଲର ନିକୋସାଇଡ ତ ତମେ ସେଟା ହିଟ୍ ଆଣ୍ଡ ଟ୍ରାଏଲରେ କରିବ बस ଏବେ थर्ड ऑर्डर सिस्टम ପାଇଁ ଖାଲି ତମେ ଜିଗ୍ଲର ନିକୋସାଇଡ ଟ୍ରାଏ କରିକି କରିବ ବାକି ଦିଟା ତମେ ହିଟ୍ ଆଣ୍ଡ ଟ୍ରାଏଲରେ କରିବ ଠିକ ଅଛି ବୁଝିଲ ନା ନାଇଁ ସିମ୍ପଲ स्टेप रेस्पॉन्स बस ଏଇଠି ट्रांसफर फंक्शन ଗୋଟେ फर्स्ट ऑर्डर एग्जांपल ନବ ଗୋଟେ सेकंड ऑर्डर एग्जांपल for the okay this is another second order transfer function I have taken 5 divided by a square plus 6s plus 5 for that I have already derived the KPKI KD value okay so next we will go for this one this is your next experiment okay that was your 8 this will be your experiment number 9 okay to design a PID controller for speed control of a DC motor system using MATLAB Simulink okay so basically this is our this is the system okay closed loop system general features are like that input signal you are providing then controller plan then a feedback will be provided here so that whatever the error signal is generated then that will be corrected by the controller right then you are generating the output signal similarly you have to generate this one what you have to do the aim is to control the speed of the system to control speed control karuja yes to you have to control the speed of the motor yes or no speed of the DC machine right so for that I am taking is controller in the part of controller I am taking PID okay now the plant will be our DC machine then you have to control the speed right so this is the basic block diagram okay now what is the need of speed controller for controlling the operation of the apparatus then it will provide you high efficiency is it will provide some cost effectiveness okay so now how will you control the speed of the DC machine first of all this is the torque is your force into radius right this is in this function अच्छा DC motor तो समझ से पढ़ी थी right basic DC motor पढ़ी ना नहीं पढ़ी so the torque equation is force into your armature radius right so from there you have to what you have to control you have to control the speed means the rotation का control करिबो right so the value you can say if you take see this is the radius of this armature right and this is the direction it is moving right so for that if you take rotation count karibo jodi suppose the speed of the armature is I have taken capital N rpm right so in one rotation the armature curves 2 pi r 2 pi r means so 2 pi r in 60 rotation per minute is n. So for second, if you calculate 60 divided by n second, what rotation complete koruchi, right? So if like the work done, if you calculate the work done for one revolution, that will be F into 2 pi r, right? Or I can say 2 pi r tau, because F into r is equal to tau, so I can say 2 pi tau, right? So the power developed will be the work done per unit second, per unit second. So it will be 2 pi tau divided by 60 divided by n, because n is rotation per minute. So 60 divided by n, because we have to calculate per second. So it will be 2 pi tau n divided by 60, or I can say tau omega, where I can write down the angular speed omega equals to 2 pi n divided by 60. 2 pi n divided by 60. So now what you have to take is, you have to take, first of all, you have to take a DC machine in your MATLAB simulink model. समस्या ओपन करके नीचे नीचे देखो गोटे डीसी मशीन ऐड करो. Okay, go to the simulink, find DC machine. Okay, see, this is the DC machine you are taking, because here the total load is being there. Okay, this is the, you can give the field potential, everything you can find out here. So first one is your DC machine. You can select this one. Okay, you can take the DC machine. Okay, now what you have to do? See, I have taken the DC machine here. Okay, so here I will provide the total load, and the specification for DC machine you can take like this. See, there are preset model. Many preset models are there. I have taken 5 horsepower, 240 volt, 1750 RPM, and field 150 volt. I have selected this DC machine. Okay, this DC machine I have taken, and here you can write down the torque. Total torque is being provided here. Okay, you can select these two. Okay. Now, what you have to do is, you have taken the field voltage is 150 volt and 1750 RPM you have taken. So here in the field you can write down F plus F minus is the DC voltage source you will add, and that will be your 150 volt, right? The required field voltage specified is 150 volt, so you have to take 150 volt. Okay. Now, what you have to do is, so the power of the DC machine is 5 SP already given. So that will be 5 into 746 watt, that is 3730 watt, right? And the speed already mentioned is n is equal to 1750 RPM in the specified box, specification box, right? So now by using these values, you can find out the angular speed, that is 2 pi n divided by 60. 2 pi 1750 divided by 60, that is 183.23 radian per second. Okay, and the total load torque will be P divided by omega, right? So you know the power is 3730 watt divided by your angular speed, that is 183.23. So that will be 20.35 nanometer. That is your full load. That is your full load. So you have to provide the full load here, 20.35. Now, for the armature, you can give a control voltage source, right? You can apply a control voltage source which will provide a control voltage unit to this armature. Okay, now the PID controller should control the speed, right? So what you have to do, you have to control the speed of the DC machine. So how will you control the speed of the machine? There are so many factors you can control. You can control the flux, you can control the field, anything is there, right? So you have to control the speed, specified speed. So what you have to do, you can add a bus here. You can add a can add a bus selector here. Okay. So after that, in this, wait, add one bus selector. After adding the bus selector, okay. So let's see. See, by default, the signals in the bus is there, signal 1, signal 2. It will look like this. It will look like this. You have to remove these signals. You have to select signal 1 and remove. Then you have to select signal 2. Then you can remove. Okay. Now, see these options are available or not. Please check whether in your system these systems are available or not. Check. সেটা থেকে check করো whether you are getting this or not. Is it visible to you? ତମେ ଏଇଟା କନେକ୍ଟ କରି ସାରିଲା ପରେ ତମକୁ ସେ ଅପସନ୍ସ ଗୁଡାକ ଦେଖଉଛି ତ ନା ନାଇଁ ଦେଖୁନି ଗୋଟେ ବସ୍ ସିଲେକ୍ଟର କନେକ୍ଟ କରି ସାରିଲା ପରେ ତମକୁ ଅପସନ୍ସ ଦେଖଉଛି ନା ନାହିଁ ଏସି ମେସିନ ସ୍ପେସିଫିକେସନ୍ସ ଦେଖଉଛି ତ ସ୍ଲୋ ହଉଛି ପୁରା that's why asking you. After connecting this signal 1 remove signal because the boss type to select again I am showing you this one okay if I remove this one okay connection যদি তুমি DC machine को देई ना then your block will look like this খালি simple থিব তুমি connection দেই সারিলা পরে এই connection টা গোটে থর দেই সারিলা পরে ঠিক আছে you will see whether these parameters are coming or not speed armature current field electrical curve আসছে না নাই DC machine सहित bus को connect कला पर these four parameters are coming in this block or not P1 P1 alright right so you have to select which one speed okay you have to select your speed then Click on speed, then select. Click on speed, then select. Okay. So then you will get a single line. Okay, that is your speed. Here you can see it's already written speed omega m radian per second. Yes or no? So now what you have to do, you have to control the speed. Our block diagram, if you go back to the block diagram. This is the block diagram. What you have to control? You have to control the speed of the machine. Right. You have to control the speed of the machine. So how will you control? Before that, we have to provide the speed in the feedback path. Right. To provide the speed in the feedback path, what I have taken one gain, that is 30 divided by pi. 30 divided by pi. Why? Can anyone tell me why I have taken 30 divided by pi? 2 pi n by 60, right? Omega equals to 2 pi n divided by 60. If I go for calculating the RPM, n, that will be omega into 60 divided by 2 pi. Right? So the angular speed will be multiplied by 60 divided by 2 pi. That is, I can say 30 divided by pi. 30 divided by pi. That's why I have taken the gain of 30 divided by pi here. Okay, gain means it will get also automatically that will be multiplied, right? Omega into 30 divided by pi. बुझिପାରିଲ ना नहीं? Our formula is see, omega equals to 2 pi n by 60. Now n equals to omega into 60 divided by 2 pi. Omega into from this equation you can write n equals to omega into 60 divided by 2 pi, right? So it will be 30 divided by pi, omega into 30 divided by pi. So this gain series रे लगिले obviously gain multiply हबो सेति तो जानि जो ना नहीं ना नहीं right. So this is already omega n we have taken radian per second into this gain. Why this gain? Because we have to multiply 30 divided by 5 here in this part. Now I am taking this n. N is in RPM. ତମେ ତମେ ଗୋଟେ ଅଲଗା ବି ସିଲେକ୍ଟ କରିକି କରିପାରିବ ମୁଁ ଏଟା କରିଛି ଡଜન્ટ ମିନ୍ କି ତମେ ବି ଏଟା ହିଁ କରିବ ଓକେ ତମେ ଅଲଗା ନେଇକି ବି ଟ୍ରାଏ କରିପାରିବ ଠିକ ଅଛି ମୁଁ ନେଇଛି 5 ହର୍ସ ପାୱାର 240 ଭୋଲ୍ଟ 1750 rpm field 150 volt okay so now I have taken this one in the feedback path okay this one I have taken in feedback path okay so now this armature I am providing the control voltage with this negative one here and I am providing the PID output here. Okay, that will provide a control voltage. Okay, hence the speed of this one will be controlled, right? So the whatever I have taken the specification, according to specification, here it is 1750 rpm, right? That's why the reference speed is 1750 rpm. That is our reference value. We should get the reference value match karna katha, right? So first of all, you can take your PID controller without tuning. Okay, you can take your PID controller without tuning. If you take without tuning, and the load I have already told you, full load is 20. Calculation कहली 20.35. Okay, now if I say Simply ଗୋଟେ PID block is there, right? If you run this one, okay, this will take too much time. Okay, here I am showing you. Okay, see, if you are taking simple, whatever we are taking there, I have done that one. Just run it for 2 seconds, and you will see you will get 1715. Okay, here I am getting 1715. Okay, so this is not a perfect match, right? You haven't tuned the PID controller, and your output will look like this. Okay, your output will look like this because I have connected the scope here. By using a box. Why I am using a box here? Because I want to see the comparison of this output with the reference value. This one I have taken the reference value, the end one, and the upper one is my output, actual output with the reference value. I am taking to the scope, and you can see this one is a power GUI unit. You have to add a continuous that will provide a continuous power to your system. Okay, so you have to add this one continuous power GUI unit. You have to add. This is available in your simulator. See this one. This one you can add. Okay, that will provide continuous power to the system. Okay, so how will you tune? हमको the transfer function जाना नहीं, right? How will you tune this PID controller? Auto tune method. You will use the auto tune method. Okay. First you have to take the untune one. This time I am getting very less value. Okay. So now how will you tune this one? Just go to the PID. Okay. Go to the PID. See, there is a tune option here available. It's not showing. See, with 110, means only PI value is there. Okay, with 110, okay, at coefficient 100, I am getting 1715. Value I am getting 1715. Okay, with these parameters. Okay, now we have to tune this one. So apply this. Auto tune method is available in MATLAB. Okay, you can go for that one. Tune this one. Okay. I don't know whether you are doing it simultaneously or not, but तुमको इतना पूरा run करेगी without tuning, with tuning next lab में show करेगा पड़ेगा. The entire simulate model. Okay, am I clear to you? So next week we will have 2 labs. Okay, in the next week we will have 2 labs. So in the first lab, only B1, in the Tuesday only B1 students will be there, and both the experiments, first order, second order PID, and this one, we will verify, and Saturday we will verify of B2 students. Okay, what is the possible होनी? It will take a while. See, after you tune this one, you will get, this is the reference tracking, this is the tuned response. The solid line is the tuned response and the block response is like this one previously. Okay, so now what you have to do, you have to update the block. Click on update the block. Okay, update block option, you have to click on that one. See, now the value is being updated. Previously, the value you can see here. Controller parameters are provided here in the right side corner. B is equal to this one. P, I, and D, and values are provided here, right? So that is being updated in your PID block. Okay. Now what you have to do? You have to just click on OK. Now again run. Again, you are getting 1750. See, whatever your reference value you are giving here, you are getting 1750. Now, go for scope. See, oscillation कम हो जाएगी. This yellow one. Okay, this blue one is your reference value. Okay, and this one is your generated out. You can take by changing the, you have to change the background. Okay, and modify the scope output. मैंने तुम्हारा lines की अगर width टिका अधिक करिवो, background change करिवो, then you have to save the output. Okay, or else you can by generating the command, by taking the command line, you can generate the output also. Okay, सेटा भी नहीं करिवो तो. और जब तमे एमती scope का output नौचो, ताले scope का background change करिके नवा को try करिवो. Okay, so now if you are going to verify this one, what you have to do, you have to take, this is the full load I am taking, right? So now you can take half load. With different loads you have to observe. With different loads you have to take, observe your output. This is the full load is 20.35. Now you can take half load and verify that one.
मैम लो टॉर्क ब्लॉक ର ନାଁ କଣ କି?
Sorry, I didn't get you.
मैम लोड टॉर्क ब्लॉक जोड़ा ଥିଲା ତାର
ସେଠି ତ କିଛି ବ୍ଲକ୍ ନଥିଲା ରେ. କୋଉଟା ଲୋଡ୍ ଟର୍କ? This one.
यस मैम.
ଏଇଟା ଗୋଟେ କନଷ୍ଟାଣ୍ଟ ଖାଲି ମୁଁ ପ୍ରୋଭାଇଡ କରିଛି.
ओके मैम.
See, constant block, constant value ଗୋଟେ 2.35 value. ତାର ତ value ଟା ତମେ ଖାଲି ପ୍ରୋଭାଇଡ କରିବ. ବୁଝିଲ?
यस मैम.
So this is our full load is 20.35. Then half you can take. Half is now L is the full one. Then I can say this is tau L divided by 2. That is 20.35 divided by 2. That's wrong. 10.17. Right. Now again 1/4 load रे देखिबो tau divided tau L by 4 means tau divided by 4. Tau L divided by 4, that will be 5 point something, 5.08 something. Okay. This one, then change this one, then change this one. And you have to check whether you are getting same speed or not. Okay. So what you have to observe is you have to compare the response with different load. Okay, that is your observation. Eligible? B1? B1? Any other doubt? Who group Roshan? हाँ ट्यूसडे B2 ର ହବ ତ କହିଲେ B1 ର ହବ ନା B2 Saturday ହବ ट्यूसडे B1 ଗ୍ରୁପ ର ଭେରିଫାଇ ହବ Saturday B2 ଗ୍ରୁପ ର ତମର ଯୋଉ ଲ୍ୟାବ ଅଛି ଯୋଉ ଦିନ ସେଇଦିନ ହିଁ ହବ ହଁ ଠିକ ଅଛି ଯଦି ଗୋଟେ ସପ୍ତାହ ସେମିତି ହବ ତମକୁ ରେକର୍ଡ ବି ହାର୍ଡୱେର ସବମିଟ କରିବାର ଅଛି ଜାଣି ସାରିଥିବ ବୋଧେ ସରି ହାର୍ଡୱେର ମାନେ ହାର୍ଡ କପି ସବମିଟ କରିବାର ଅଛି hope you know that right all of you
Yes, ma'am.
record भी अपडेट करो next week next week you have to submit the record also ମୁଁ କିଛି ଜାଣିନି ଯୋଉ ଟାଇମ ରେ ଲ୍ୟାବ ଅଛି B1 ଗ୍ରୁପ ର ଯୋଉ ଟାଇମ ରେ ଲ୍ୟାବ ଅଛି ସେଇ ଦିନ ସେଇ ଟାଇମ ରେ ଭେରିଫିକେସନ ପଢିବା ପାଇଁ ସଫିସିଏଣ୍ଟ ଟାଇମ ଅଛି କାଲି ଗୋଟେ ଦିନ ଅଛି ପୁରା ପଢ ମଡେଲ ତିଆରି କର ମଡେଲ ଭେରିଫାଇ କରିବାର ଅଛି ଦିଟା ଏକ୍ସପେରିମେଣ୍ଟ ଟ୍ୟୁସଡେ ଏବେ ବସିକି କର ଏବେ ଆହୁରି ଘଣ୍ଟାଟେ ଟାଇମ ଅଛି ନା କର ତମମାନେ କଲେଜ ଆସିଲା ପରେ ଲ୍ୟାବ ଯୋଉମାନଙ୍କର ଆବସେଣ୍ଟ ଯେତେଟା ଅଛି କମ୍ପେନସେଟ୍ କରିବ ଦେନ୍ ଲ୍ୟାବ ଟେଷ୍ଟ କଣ୍ଟ୍ରୋଲ ଲ୍ୟାବରେ ଦବ ଠିକ ଅଛି ଠିକ ଅଛି ନା ନାଇଁ ଅଫଲାଇନ ନେକ୍ସଟ ୱିକରେ ଇନଫର୍ମ କରାହବ ଲ୍ୟାବ ଟେଷ୍ଟ ହବ ହେବା ପାଇଁ ପ୍ରିପେୟାର ତ ନେକ୍ସଟ ୱିକରେ ତ ଆଟଲିଷ୍ଟ ଏଇ ଦିଟା ଲ୍ୟାବର ତ ଭେରିଫିକେସନ ଅଛି ଗୋଟେ ହଉଛି ଏଆଇଡି ଡିଜାଇନିଂ ଆଉ ଗୋଟେ ସ୍ପିଡ କଣ୍ଟ୍ରୋଲ you can share your screen if you have completed you can share your screen if you have completed
Ma'am, can I share? Ma'am, এটা without tuning ର ମ୍ୟାମ୍ ଏଇଠି ଆମେ ପାୱାର GUI କାହିଁକି ୟୁଜ କରୁଛେ
continuous power provide କରିବ interface
so this is the output I'll change the background color এটা tuned କଲା ପରେ
okay tune କଲା ପରେ ତମେ ଆଉ ଗୋଟେ ଜିନିଷକୁ ଚେକ୍ କରିପାରିବ whether it follows the reference value or not ସେଠି ଯୋଉ reference value କଣ ଅଛି 1750 rpm ଦେଇଛ ତ ତମେ ସେଇଟା ବି ଚେଞ୍ଜ କରିକି ତମେ ଦେଖିପାରିବ
1750 ଏଟାକୁ କଣ ଚେଞ୍ଜ କରିବେ ମ୍ୟାମ୍
ଅଲଗା କିଛି ଭ୍ୟାଲ୍ୟୁ ଦେଇକି ଦେଖ ପୁଣି ଏଇଥିରେ ରନ୍ କର 1500 ଦିଅ ସପୋଜ 1500 rpm କରିଦିଅ okay then again run karo whether you are getting the same value or not Same ଆସୁଛି ତ 150.
Yes, ma'am. Yes, ma'am. 1500. ଆଉ ଏଇଟା tuned ପରେ ଏମିତି
ଏଇଟା ନୁହଁ, ଏଟା ତମର ଯୋଉ ରେଫରେନ୍ସ ଟ୍ରାକିଂ ବାଲା ବ୍ଲକ, ସେଇଟା ସ୍କୋପ ରେ ହିଁ ଯୋଉଟା ଆସିବ ସେଟା ହିଁ ତମର ଆଉଟପୁଟ ଫାଇନାଲ ଆଉଟପୁଟ।
ଓକେ ମ୍ୟାମ୍ ମାନେ ଏଇଟା ଦବାର ନାହିଁ ନା ଫାଇନାଲ ଆଉଟପୁଟ ପାଇଁ?
ନାଇଁ ଟ୍ୟୁନ୍ କଲା ପରେ update the block, then again whatever you are getting in the scope, that is your final.
ओके मैम। मैम स्टॉप करिए।
Anyone else?
Yes, ma'am.
ପାୱାର ପଏଣ୍ଟ ରେ তুমি ଚେକ୍ କରିପାରିବ, ସେଠି ଅଲଗା ଅଲଗା ଅପସନ ବି ଥିବ, କଣ୍ଟିନ୍ୟୁଅସ୍, ଡିସ୍କ୍ରିଟ୍, ଅଲଗା ସିଷ୍ଟମ ପାଇଁ ଅଲଗା ଥିବ, ଠିକ ଅଛି। ତମେ ତମର ସ୍କୋପ ର ଆଉଟପୁଟ ଟାକୁ ବି ଟିକେ ଜୁମ କରିକି ଦେଖିପାରିବ, whether it is ମାନେ ତମର କଣ ଆସୁଛି, ସେଟିଂ ଟାଇମ କେତେ ଆସୁଛି, ତମେ ସେଇଟା ବି ଚେକ୍ କରିପାରିବ। ঠিক আছে, then you can change your load and verify. তো তোমার observation কোন ରହିବ, different load ପାଇଁ theoretically sorry untuned parameter କେତେ ଆସୁଛି, tuned parameter କେତେ ଆସୁଛି, load change କରିକି ଦେଖିବ ବାସ୍। ହଁ, compare the response with different load। share କର। ବାକି ଲ୍ୟାବ୍ ନେକ୍ସଟ ୱିକରେ ଅନଲାଇନ ହବ, ଆଉ ଯୋଉ ଟାଇମରେ ହବା କଥା ସେଇ ଟାଇମରେ ହିଁ ହବ। ଟ୍ୟୁଜଡେ ଯୋଉମାନଙ୍କର ହବା କଥା ଯୋଉ ଟାଇମରେ ହବ, ସାଟରଡେ ଯୋଉମାନଙ୍କର ଯୋଉ ଟାଇମରେ ଅଛି ସେ ଟାଇମରେ। କାହିଁକି ନା ଗୋଟେ ଗ୍ରୁପ ଦି ଦିନରେ କଲେ ମୁଁ ଭେରିଫାଇ କରିପାରୁନି, ବେଟର ଟ୍ୟୁଜଡେ ଭେରିଫାଇ କରିବା ଅଧା ଜଣଙ୍କର, ଦେନ୍ ସାଟରଡେ ଅଧା ଜଣଙ୍କର।